This is AP Calculus 7-8 Exponential Models with Differential Equations. And a model for exponential growth and decay are derived from the differential equation. And we've talked a little bit about how to solve these already, but I want to make sure you understand where your setups and everything are coming from in this section. So we're going to first just solve this simple differential equation, and then we're going to get into a few word problem examples. So if I'm going to solve this differential equation, the first thing I have to do is separate the variables. Once I've separated the variables, I'm going to put in the integration symbol and integrate. So here I have separated the variables. Next, I'll put in the integration symbols. And at this point, I will integrate this. The left side is a natural log situation. Over here, we've got a constant times dx. So this constant will be integrated with respect to x. So on this side, I'll have the natural log of the absolute value of y, and that equals kx plus c. Remember, we need the c, the constant, because we don't know what constant could have possibly been there. And then we learned in the last section to eliminate the natural log, we're going to put the e in front. And when we put the e in front, remember this is e to the kx times e to the c, and that e to the c is still a constant, so it goes to the front. And so this is our basic formula when we're solving a simple exponential growth and decay problem. This is the derivative, or this is the derivation of kind of the form that everything will take. A lot of times instead of x here we'll have t. Everything will be in terms of time, like hours, days, minutes, whatever the time variant would be. And then your y is your f of t if you choose to express it that way. Population y grows according to the equation dy over dt equals ky. So this time you're finding your y function with respect to t time, where k is a constant and t is measured in years. If the population doubles every 10 years, then the value of k is, okay, so they're just asking us to find k here. So first thing I'm going to do is separate the variables. So that would give me dy over y equals k dt. Then I will integrate both sides. And when I integrate, I have natural log of y equals kt plus c. I will get rid of the natural log by putting an e in front. And at this point, you have seen this happen several times now, and you're always going to have the same thing. When you have e to the kt plus c, that will always end up being ce to the kt, because e to the kt plus c is e to the kt times e to the c. That e to the c is a constant, moves into the front. So it is okay to go straight from here to here. Know that that's going to happen every single time. Some people actually memorize from this down to this, and they know this is the formula they'll always end up with, which is fine if you like to memorize things. I don't like to memorize. I know that when I memorize things, sometimes I forget little details, and those forgetting little details will keep me from getting things right. So I don't tend to memorize. I tend to do that every time. Whatever you decide to do is fine. Both ways work perfectly well. So y equals ce to the kt is my formula. They tell me that the population doubles every 10 years. So it takes, if t is 10, that means my population will double. Well, if c is my initial population, what I'm going to do is just pick a random initial population. I'm going to say my initial population is 1. Well, it'll take it 10 years to double to 2. So if my initial population is 1, and you could say it's 100, then it will double in 10 years, that's my time, to 200. So that would be my y value, my final answer at the end of this situation. And they're just asking us to find k. So if I do this, I will divide the 1 over. That gives me 2 equals e to the 10k. If I put a natural log in front, I'll have natural log of 2 equals 10k. And then to get my k value, I'm going to divide by 10. And when I divide by 10, I end up with 0.069. And looking at that, A would be my answer. In this one, it says dy over dx equals 4y. And if y equals 4 when x equals 0, then y equals. So I'm going to go ahead and let you do this one on your own. See if you can get the correct answer, and then I'll share that with you in just a minute. So hopefully you got A for this one. I first separated the variables, and then I integrated, put an e in front to get rid of the natural log, ended up with y equals ce to the 4x, and then I plugged in the ordered pair 0, 4. Leaving me with the c value of 4, giving me the equation y equals 4 times e to the 4x. This one says solve the differential equation y prime equals 3x over y. This one is very similar to one we did earlier. With this, the real thing you need to understand is dy over dx is the same thing as y prime. So we replace that, dy over dx. Go ahead and pause the video, see if you can do this, and then I'll give you the answer in just a minute. And here is your answer. In this case, since y squared is equal to 3x squared plus c, I did not take the square root. There's nothing wrong with that, but I tend to leave it like this if I've got a c that hasn't been solved for, unless this is a number. If I take the square root, I'm still not going to know really what that is, and so I tend to just leave it like this. So I replaced y prime with dy over dx, then I separated the variables, leaving me with y dy equals 3x dx. So you're not always going to have a natural log situation. Most of them that we've had so far did have a natural log, but this one is one that does not. I want to make sure you understand the difference between those. And then I integrated both sides, so I end up with y squared over 2 equals 3 halves x squared plus c. And then I multiplied by 2 on both sides, leaving me with y squared equals 3x squared plus c. Understand that is a 2c, but since c is a constant anyway, we don't know what it is. So we don't know what 2c is either, so there's no problem with just naming it c. So you don't have to multiply the c, just bring it down as c, a constant. It's still going to be a constant. Really doesn't matter that it's been multiplied by 2. A slow economy caused the company's annual revenues to drop from $530,000 in 2008 to $386,000 in 2010. If the revenue is following an exponential pattern of decline, what is the expected revenue in 2012? Well, they give you an initial revenue in 2008. So this can really represent an ordered pair. This would be time 0 because this is when the problem started. So at time 0, we have $530,000. That's really an ordered pair in the situation. And then the second ordered pair that they give us is you have $386,000 in 2010. So what that means is at year 2, because that's 2 years after we started, we have $386,000. That's another ordered pair. And they want to know if the revenue is following an exponential pattern of decline, what is the expected revenue in 2012? Well, in 2012, if we started in 2008, aren't they asking us for the revenue 4 years after the beginning of the problem? So we know our x value is going to be 4, and we're trying to find what the value will be. All right, so if we set this up, this is an exponential growth and decay problem. We know that the exponential growth and decay equation is y equals ce to the kt. We've derived it many times already. So we can now use this as a formula to solve one of these problems. And what they're basically telling us is at time 0, our initial amount is $530,000. So this will be our c value, giving us a formula for this specific situation. Now, we will have to figure out what k is in order to be able to answer our question. But to find k, they have given us a second ordered pair. So the next thing I'm going to do is plug this ordered pair in to identify what the k value will be. The 386,000 will go in for y, and the 2 will go in for the t. At year 2, we have $386,000. So I'm going to divide both sides by $530,000. Now when I do that, I'm going to leave it as a fraction. I only want to round at the very end of my problem. I don't want to round more than once because every time I round, my answer gets a little bit less accurate. If I put this in my calculator, 386,000 over 530,000, I end up with 193 over 265, and that equals e to the 2k. So to get rid of the e, I'm going to put a natural log in front of both sides. Once I've done that, my e will cancel out, leaving me with 2k, and I will have the natural log of 193 over 265 still on this side. Again, I'm being real careful not to round this more than once, so I don't want to round until I'm getting my final answer. So I'm going to divide by 2. When I divide by 2, the k value will be this expression right here. So then if that is my k value, I'm going to plug that back into my original. I know that my c value is still 530,000. That's the initial amount. So I'm going to rewrite my equation. So putting that information in, this is what I have. The next step is I'm going to replace the t with a 4. So when I replace that with a 4, I now have something that I can put into Desmos or my calculator and solve. And I will be able to then round this answer to get my final Y value in 2012. Okay, I want you to see my computer screen or my calculator screen so that you can see how I entered that into my calculator so that I only have to round it one time. So here it is on my screen. Hopefully you can see that. That's how I entered it into my calculator. That first number is 530,000, and then I have the E, and then this is the power, all those parentheses and everything. And then I'll just hit execute. And when I hit execute, I end up with, now, normally I would round to 3 decimal places with a problem like this, but since this is a money value problem, I'm going to round to dollars and cents. So that would be 0.53, rounding just to 2 decimal places. So I end up with $281,124.53 in the year 2012. Suppose a population of insects increases according to the law of exponential growth. There were 130 insects after the 3rd day of the experiment, and 380 insects after the 7th day. Approximately how many insects were in the original population? So again, this is an exponential growth and decay problem, so y equals ce to the kt. In this problem, they have given us a couple of ordered pairs. After the 3rd day, we had 130 insects. That's an ordered pair 3, 130. After the 7th day, they had 380 insects. So 380 insects after the 7th day is an ordered pair 7, 380. And they want to know approximately how many insects were in the original population. So they want us to find C. So this one's a little bit different. We don't know what C is for either of these, but we can use these values to help us find K, and then we will kind of work backwards to find C. So we don't know how many are in our initial population, but we do know that at 3 days we have 130. So when T is 3, Y is 130. So I'm going to plug that in first. And notice I switched this around to, our T is 3. So it makes more sense to write that as 3K. And then if I plug the second ordered pair in, I have 380 equals CE to the 7K. So maybe you'll notice here, we have 2 equations with 2 unknowns. So I can solve this using systems of equations. Since we know that C has to be the same for both of these in order for this situation to work, then couldn't I get C by dividing by e to the 3k here? And over here, I could get C by dividing by e to the 7k. So I have, for the first equation, 130 divided by e to the 3k equals C. And for the second equation, 380 over e to the 7k equals C. So now since both of these equal C, I can set these two equal to each other. Then I'm going to do some algebra to solve. I'm going to cross multiply. So when I get it to this point, this can be tricky. What you want to do is you only want one e in this problem. So couldn't I divide both sides by e to the 3k and get that e to the 3k over here with the 7k? So if I divide both sides by e to the 3k, wouldn't over here I have 138 e to the 4k? And then couldn't I divide the 138 on the other side and get the e by itself? So I would have e to the 4k equals 380 over 138. Then to get rid of the e, I would put a natural log in front. And then if I take this and divide by 4, see this natural log of e cancels. So I have 4k equals natural log of 380 over 138. So if I find natural log of 380 over 138 and then divide by 4, I will have my k value. So this is the expression for my k value. So if I find the k value and then plug that k value back in here, couldn't I find my c? Or I could plug it back in here and find my c. So go ahead and do this on the calculator. Find your k value. In my calculator, I'm going to then put 380 over and then e to the 7 times that answer. And that will give me my c value, which ends up being, so that gives me c equals 64.558. And I'm going to round to the nearest insect. So that would be c equals 65. Depending on how many times you round, this answer can vary sometimes. So I didn't round anywhere in this problem until the very end so that I could get the most accurate problem possible. Sometimes, though, they're going to tell you to round your k value to 3 decimal places and then plug it in. Just pay close attention to what the directions are telling you to do so that you make sure you're getting the same answer that I'm getting. So here's one I want you to try on your own. A herd of llamas has 1,000 llamas in it, and the population is growing exponentially. At time t equals 4, it has 2,000 llamas. Write a formula for the number of llamas at an arbitrary time t. So this is an exponential growth and decay problem. Go ahead and pause the video, see if you can get that equation. So all they ask us in this one is to come up with an arbitrary formula. So we know the initial population of llamas is 1,000, so that would be our C value, our initial population. They tell us at time t equals 4, we have 2,000 llamas, so 4 will be your t value and y will be 2,000. I plug that into the equation as well. And then I'm going to divide 2,000 by 1,000, giving me 2. And that still gives me e to the 4k. I put a natural log in front. Natural log of 2 equals 4k. Divide by 4. So my k value is natural log of 2 over 4. So that leads me back to the equation, y equals 1,000 e to the k, natural log of 2 over 4, times t. That would be my arbitrary equation that they asked me for. A colony of bacteria is growing exponentially. At time t equals 0, it has 10 bacteria in it, and at time t equals 4, it has 2,000. At what time will it have 100,000 bacteria? So they want you to find the t value this time for 100,000 bacteria. Go ahead and pause the video, see if you can get this on your own. Okay, so for this one, the initial C value at time equals 0 is 10. So I put the 10 in for C. It takes 4, or at time 4, it has 2,000 bacteria. So 4 was our T value there, and I put, or 4 was our T value, I put 2,000 in. If I divide by 10, I get 200 equals e to the 4k. To get rid of the e, I put a natural log in front. And then if I want to get k by itself, I divide by 4. So my k value here is natural log of 200 over 4. And then I plug that back into the original equation. So y equals 10 is still our initial amount. E to the natural log of 200 over 4, t. And then I take that equation and I plug in this 10,000 bacteria for our y value, because that's how much we have after a certain amount of time. We're trying to find the time that happens. So 100,000 divided by the 10 is 10,000. I still got the e to the natural log of 200 over 4 times t. To get rid of the e, I put a natural log in front of both sides. So now I have natural log of 200 over 4 t equals natural log of 10,000. I divide by natural log of 200 over natural log of 200 over 4. So that means I have a 4 times natural log of 10,000 over natural log of 200 equals t. And then when I put that in my calculator, I got 6.953. Now it did not tell me how to round this, whether this, and it didn't tell me what this t value is, whether it's time in years or what it is. If it asked to, like, let's say it was years and it asked to round to the nearest year, you would say 7 years. Minutes, 7 minutes, and so forth. But pay attention to what it says for rounding. If they don't give you a specific value to round to, I would do 3 decimal places every time.